Get this, if Earth were the size of a basketball, the sun would be equivalent to two iconic Hollywood signs stacked up high. That's mind-blowing, but here's where it gets even wildered. Our star is just a relatively small yellow dwarf, and there are these gigantic space giants out there that make our sun look teeny tiny, like a tiny speck of dust. In fact, scientists recently discovered an astronomical behemoth in 2024, and we're about to uncover this cosmic monster. Meet the cosmic behemoth that just dethroned all others. This supergiant star is so enormous, it could literally gobble up our sun and even half of our entire solar system. You're wondering who this record breaker is, right? Well, size isn't everything in space. Trust us, we've got some surprising facts coming your way. But first, let's reveal the identity of the new largest star after our own sun. And it's not Polaris, the North Star you've always known. Buckle up, space fans. We've got a mind-blowing revelation. Meet Ardurtas, an extraordinary star in the constellation that shares its name, and it can only be spotted from Earth's southern hemisphere. For the very first time ever, scientists successfully observed Ardurtas' surface in 2024, and let me tell you, it was a game changer. They found out that this cosmic giant is literally boiling over with scorching plasma, creating enormous bubbles on its surface. Talk about some serious space drama. Given that Ardurtas boasts an insane radius of nearly 300 times bigger than our sun, those gigantic bubbles could be as massive as our star itself. But here's the thing. Despite being the largest star we can see from Earth, Ardurtas isn't even close to holding the record for the biggest star out there. That title once belonged to a real showstopper called VY Canis, and it's still making waves in astronomy. In 2012, scientists used Childs' Very Large Telescope to size up three massive red supergiants at our galaxy's center, and VY Canis was one of them. This cosmic giant is so enormous that if you were to replace our sun with VY Canis, its surface would extend way beyond the orbit of Saturn. That's just insane. Get ready to blow your mind. VY Canis' sheer size left scientists speechless, with a radius of an astonishing 1,708 solar radii. This star is not just 1,700 times bigger than our sun. It's more like, imagine one cube being the size of the sun and the other, VY Canis, engulfing over 17,000 cubes like that. Talk about mind-boggling. Let's see how volume works its magic. The white cube here represents one solar radius. That's our sun in tiny form. Now the gray cube, with its side twice as long, can hold an amazing 8 of those small white cubes inside it. That's not just about size, it's also about space and volume. But wait, let's apply this to VY Canis. If we use the same math, this colossal star could theoretically fit a staggering 5 billion suns inside its massive expanse. Or so we thought until scientists discovered they made an error. Get ready for a star that's truly gigantic. In 2023, scientists made some new measurements about VY Canis, but it lost its title as the largest known star in space. Now it's over 900 times bigger than our sun, not even close to the new champ. That honor goes to Milky Way G64, a colossal star in the Large Magellanic Cloud galaxy, an amazing 160,000 light-years away from us and safely out of harm's reach. If we were to put this monster at the center of our solar system, it would swallow 5 of its 8 planets whole. Yes, even Jupiter wouldn't be safe. OHG64 is surrounded by a massive cloud of dust and gas, created when powerful winds blow material away from its enormous surface. But wait, we're not done with the record-breaking stars just yet. The massive dust cloud surrounding OHG64 stretches over an entire light-year into space and weighs as much as 9 of our suns. Pretty mind-boggling stuff. However, you might be surprised to learn that there's actually a star that dwarfs even this incredible giant. Meet Stephenson 2D-FK1, a red supergiant that's been hiding in the shadows, overlooked by scientists until now. Could it really dethrone OHG64 as the largest star out there? Get ready to have your mind blown. Stephenson 2D-FK1 boasts an enormous radius of 2,150 times that of our sun. Yes, you read that right. It's over 2,000 solar radii in size. But here's the thing, this cosmic behemoth seems to be breaking all the rules. You see, according to physics, stars like Stephenson should have a limit to how large they can grow before they start to destabilize and self-destruct. This limit is called the Hayashi limit, but Stephenson somehow manages to smash right through it, not once, but twice. So, what's keeping this giant from falling apart or collapsing under its own gravity? It all comes down to a precise balance between the inward pull of gravity and the outward push of internal pressure, a delicate dance that keeps Stephenson in check. But wait, there's a twist. Despite being a record breaker with its enormous radius, Stephenson 2DFK1 also defies expectations when it comes to temperature. The laws of physics say that stars like this should be scorching hot, but instead, Stephenson's surface temperature is surprisingly lower than what we'd expect. Only 300 kelvins shy of the coldest supergiants out there. This mind-bending anomaly raises some serious questions. Are our measurements way off, or do we need to rethink the laws of physics as we know them? Right now, another contender takes the crown for largest star in the universe, WAG-64. But hold on to your seats, folks, because size isn't everything when it comes to these cosmic giants. You know what they say, don't judge a book by its cover, and that's especially true when it comes to stars. We've been talking about how big some of these space giants are, but size isn't everything in the universe. What really sets some stars apart is their incredible luminosity. That's right, hypergiants aren't just about being huge, they're also about shining super bright. But if we're keeping track of the real record breakers, let me show you the true champion. Meet Arvan 36A1, a star that's not only enormous but also packs an explosive amount of light. Its radius is a staggering 2 times bigger than our sun. Buckle up, folks, this one's a cosmic superstar. But here's the bombshell, R136A1 isn't just a size record holder, it's also part of a Star Athlete Hall of Fame. This cosmic powerhouse boasts an insane mass of almost 200 times that of our sun, making it one of the heaviest hitters in space. In fact, it's only second to its neighbor BAT99A98, which takes the crown with a mass exceeding that of our sun by an astonishing 350 solar masses. Yeah, you read that right. However, these records won't stay unchallenged for long, as stars are constantly burning out or exploding in spectacular fashion. The universe is always throwing a curveball, and we can't wait to see what's next. Now let's talk about how these superstar giants lose their massive weight, literally. R136A1 and BAT99998 are being stripped bare by incredibly powerful stellar winds. We're talking speeds of up to 2,600 kilometers per second for R136A1. That's almost 1.6 million miles per hour. To put it in perspective, imagine losing around 5 entire suns worth of mass since its birth. That's right, this star has already shed a whopping 5 solar masses just from these intense gusts. And if you think that's insane, wait until you hear about its brightness. We're talking astronomical levels here. Let's put this into perspective. If our sun were shining like R136A1, Earth would be toast. Temperatures would skyrocket to a scorching 16,200 Kelvin. That's nearly 3 times hotter than the surface of our own star. But here's the amazing part, R136A1 isn't even the brightest light in the cosmic show. It ranks 7th on the list. That title belongs to a superstar known as Godzilla, located in the Sunburst Galaxy. Yeah, you read that right. This behemoth of a star is actually called Godzilla. Get ready for some mind-blowing stellar stats. Godzilla from the Sunburst Galaxy might be bright, but R136A1 leaves it in the dust. It's an astonishing 255 million times more luminous than our sun. However, when it comes to heat, R136A1 takes the lead. Its surface temperature is a sizzling 6,000 Kelvin, which is roughly 1.5 times hotter than Godzilla and 8 times hotter than our own star. But don't crown R136A1 as the champion just yet. That title goes to a tiny but fierce underdog called WR102 with a radius smaller than half of the sun's size. This stealthy star packs an incredible punch and takes the cake when it comes to extreme heat. Buckle up, space fans. We've got a real firecracker in WR102. This tiny but fierce star is not only scorching hot, with temperatures reaching an insane 200,000 Kelvin, but it's also one of the most destructive forces in space. Its extreme stellar winds are stripping away mass at a mind-boggling rate. We're talking hundreds of millions of times faster than our own sun. This intense outflow, combined with powerful UV radiation, is compressing and ionizing surrounding interstellar gas, creating a massive bubble-like nebula around the star. Imagine if our sun even got close to WR102's heat. It wouldn't just melt the polar ice caps, but actually boil away entire atmospheric layers, including sand particles. So, let's give it up for WR102, the tiny titan of cosmic destruction. The cosmic record books are about to be rewritten. WR102 is nearing the end of its reign as the hottest star in the universe, and scientists predict it could soon explode as a supernova. But don't worry, our planet will survive. We're looking at a star that can vaporize most chemical elements on Earth. As WR102 prepares to pass the torch, we've got another contender vying for the title, Arvin 36A1. This rare superstar may not have broken any records in a single category, but its unique combination of mass, brightness, and temperature makes it an one-of-a-kind oddball. Think of it as the universe's version of the longest walk on Lego bricks. It just goes to show that even in the vast expanse of space, there are champions and underachievers, each with their own special place in the cosmic record books. You thought massive stars were the ultimate cosmic showstoppers. Hold on to your space boots. The real mind-bender is actually one of the universe's tiniest stars, EBLM J555721 AB. This teeny titan has a radius and mass that are just 8% our sun's size, making it the smallest star we've ever discovered. But here's the crazy part. Despite its miniature size, this pent-sized star is still churning out nuclear fusion in its core. Talk about packing a big punch in a small package. But wait, it gets even wilder. EBLM J555721 AB is actually smaller than Jupiter, our gas giant king. So why hasn't Jupiter turned into a star? The reason lies in mass, and it's a crucial difference. Our massive Jupiter has a whopping 1,000th of the sun's mass, which isn't enough to spark nuclear fusion. But here's the thing, stars aren't bound by these rules. They're the rebels of space. This tiny star's size is just one of the many secrets it keeps. And we can't wait to uncover more about this cosmic underdog. Get ready for a real brain twister. Meet PSR Ballard 943+10, a star that'll blow your mind. This neutron superstar is spinning around its axis in just 1.1 seconds. That's faster than a high-speed camera. But hold on to your seat, because the real shocker is its size. This pulsar is a minuscule 2.6 kilometers across, smaller than you'd expect from even the tiniest space rock. Yet, despite being teeny tiny, it packs enough of an energy punch to wipe out life on our planet. Talk about a force to be reckoned with. But wait, our record-breaking pulsar's super-spinning days are numbered. It's destined for inevitable slowdown and ultimate demise as a cold, lifeless core. That's a sad ending to its cosmic story. On the other hand, we have a real marathoner in space. Meet IPTF4HLS, a supernova that refuses to slow down. Discovered by UC Santa Barbara scientists back in 2014, this stellar runner exploded over 500 million light-years away from us and is still going strong, defying all expectations and redefining what we thought was possible for these cosmic events. At first glance, this celestial event appeared to be just another ordinary supernova wall. But boy, were we in for a surprise. Between 2014 and 2019, scientists witnessed something truly astonishing, not one or two, but 5 massive explosion peaks, each as powerful as an individual supernova. This was like watching the same star drop multiple record-breaking beats in a row, defying all logic. And to make matters even more mind-blowing, researchers dug up some old data and discovered that this star had actually exploded 60 years prior, leaving us with a cosmic mystery that's got everyone scratching their heads. How can a star go supernova twice? The million-dollar question remains unanswered. What exactly triggered these back-to-back cosmic fireworks? One wild theory proposes that the star's core might have been cooking up some serious antimatter, and when it came face-to-face with regular matter, BAM, those two forces would annihilate each other, unleashing an energy blast equivalent to a supernova. It's like a never-ending, explosive dance of opposing particles. While we're still waiting for more pieces of the puzzle to fall into place, one thing is clear: this star's double whammy display has left us with a cosmic cliffhanger that future discoveries are sure to illuminate. And who knows, just maybe, it'll lead us to new frontiers in space exploration. The universe is full of secrets waiting to be cracked wide open, and with each new discovery, we're bound to stumble upon some seriously stellar records. Who knows, maybe the next big find will be the largest cosmic Daruma doll out there. Talk about a jaw-dropping astronomical anomaly. But let's dive deeper into this mind-bending concept. Scientists are hinting at the possibility that hidden within the heart of certain red giants, instead of just helium, you might find an actual neutron star. Think of it as a tiny, super-dense cosmic powerhouse. Now imagine what would happen when one of these red giants gets too close to another celestial neighbor in a crowded globular cluster. Their gravitational push and pull could lead to a cosmic collision that gives birth to the ultimate Daruma star. Fasten your seatbelts, space travelers, because we're about to blast off into the fascinating history of the Daruma star theory. Back in 1977, two cosmic geniuses, theoretical physicist Kip Thorne and astrophysicist Anna Zitkow, first proposed this mind-bending idea. Then, in 2014, a major breakthrough came when the Magellan Clay telescope spotted a potential Thorne-Zitkow object called HV 2112, getting everyone's cosmic curiosity piqued. But just as we thought we were onto something huge, new research 4 years later put the brakes on. It turned out that this star didn't have the needed ingredients for a Daruma star after all. You see, these hypothetical stars should be chock full of lithium, molybdenum, and rubidium. But our telescope scans just couldn't find the required levels in HV 2112. Don't worry though, science is all about taking leaps and bounds, and sometimes that means hitting a speed bump or two. The search for these cosmic oddities continues, and we can't wait to see what's next on this intergalactic mystery tour. Buckle up, space fans, because we've got some fresh updates on the Daruma star quest. In a thrilling twist, scientists discovered a new potential Daruma star candidate called HV 10217 in the same year as that initial setback. Talk about cosmic resilience. If this one gets the green light, we'll be adding it to our Cosmic Hall of Fame, right alongside other mind-bending records like the brightest dark matter star. And if you thought that was cool, fast forward to 2023 when the James Webb Space Telescope sent us a galactic shockwave by spotting not one, not two, but three more Daruma star candidates, G8DS GSC 13-0, 12-0, and 11-0. These cosmic gems are so distant that the light we're seeing from them today has been traveling through space for almost 14 billion years, taking us back to a time when our universe was just 200,000 years young. Mind blown, right? We're on the cusp of a game-changing discovery here. If scientists can confirm that these enigmatic objects are indeed stars, not distant galaxies, it'll be a breakthrough so monumental, it'll make this millennium's list of most epic moments in science. But let's take it back to the big question. Does dark matter really exist? As of now, we can't prove or disprove it, but here's what theory suggests. In the early universe, gravity pulled together clouds of hydrogen and helium, forming proto-galaxies with dark matter at their cores. The mysterious dark matter particles, which also have antimatter properties, would collide and annihilate each other, triggering a chain reaction that heated up these gas clouds, voila. Stars were born from this cosmic chaos. Could we be looking at the very first stars in our universe's history? Imagine a star so massive it's like our sun on steroids, with temperatures as high as our own sun, but packing in a whopping million times more mass and shining an astronomical billion times brighter. This mind-boggling cosmic behemoth is what theory predicts a dark matter star should look like at its peak. But what happens when this superstar reaches the end of its life cycle? Poof! It's supposed to turn into a supermassive black hole, leaving us with a trail of mystery and unanswered questions. Scientists are just one crucial clue away from confirming if these enigmatic objects are indeed dark matter stars or distant galaxies. They're waiting for a breakthrough in the electromagnetic spectrum, specifically a telltale helium isotope signal that would be the cosmic aha moment. If they find it, we'll finally have our answer and change the course of astrophysics history. While scientists are on the hunt for dark matter stars, the universe is secretly preparing to give us an entirely new record holder, the elusive black dwarf. These mysterious cosmic bodies mark the final act in the life cycle of stars like our sun. But there's a catch: they don't exist yet. You see, the universe hasn't aged enough for them to pop into existence. Once our sun runs out of fuel and sheds its outer layers, it'll transform into a scorching white dwarf, an incredibly dense star with temperatures ranging from 4,000 to a sizzling 150,000 Kelvin. But here's the thing: when a star dies inside, it loses its heat source, and that's when things get really interesting. As our sun cools down over billions of years, it'll eventually turn into a black dwarf, a dense, chilly, and dark sphere, invisible to our eyes. Get this, it'll take a whopping 1 quadrillion years for our sun to transform into a black dwarf. But since our universe is only about 14 billion years young, these chilly cosmic bodies are still nowhere to be found. But hold on to your seats. In the incredibly distant future, these black dwarfs might just become record breakers. Not only would they boast extreme density, which could potentially lead to mind-blowing explosions and even trigger some massive ones to turn into supernova, talk about a star's final hurrah. These stellar seniors might also earn the title of coldest stars in the universe, with surface temperatures dropping perilously close to absolute zero. So, who's the ultimate record holder among all stars? Well, you've learned some pretty cool stuff about black dwarfs and their potential for extreme density and record-breaking coldness. But let's not forget, there's a star that stands out from the rest in a very special way. It's our trusty neighbor and the one we see most often in the sky, the sun. Although it might not be the biggest, or heaviest, or even the weirdest space object, what truly makes it the greatest record holder is this: it's the only star we know that's home to life as we know it. You're right, only intelligent life could imagine crowning a cosmic record holder. But for us, let's look at what makes a star